Hello, so today we will discuss electricity 0 to Ohm's law and resistance. What is Ohm's law? It states that the potential difference across the ends of conductor is directly proportional to the current flowing through the conductor. More is the potential difference, more is the current. Here I have taken one conductor and applied positive 10 volt this side and 0 volt this side. This side is positive, this side is 0. If there is electron inside the conductor, that electron has negative charge, it will be attracted toward the positive plate. Now all the electrons will flow like this on applying a potential difference of 10 volt. Electron goes like this. There is a convention that the direction of current is opposite to the direction of flow of electron. It has been said, it has been made. So if electron flows like this, current goes like this. So current flows from a higher potential to a lower potential. And if the potential difference is 10 volt, we say the current is 1 ampere. Just say 1 ampere or say it I. Now I increase the positive potential on this plate and it remains 0. Now the potential difference becomes 20, which is double of the previous case, and the current also doubles. The current also becomes 2I. If you double the potential difference, current doubles from 1 ampere to 2 ampere. Why? More is the positive charge over here, more number of electron will be attracted. More number of electron will move, more will be the current. More is the number of electron that moves, more is the current. So current will also increase and the direction of current will be opposite. So as you increase the positive potential here or decrease a negative potential over here, as you increase the potential difference, current flowing inside the conductor increases. You can think like potential difference is a push to the current. More potential difference means more push, and more push means more current. So it is simple. More potential difference, more current. Provided. Temperature remains constant. This conductor must be in some room, and when you double the potential, when you change this potential, temperature should not change. What was the temperature here should be here. So temperature should remain constant. Especially all physical conditions remain same. Pressure, temperature, humidity, any light energy, any kind of electrical energy, radiation, anything in that room must not change. Then only on doubling potential current will develop, and then only it is said to be Ohm's law. That is, the temperature should remain constant. You increase the potential difference, but the temperature remains same in each case. Then only you can say delta V is directly proportional to I. So on increasing potential difference, current increases. Double the potential difference, current double. Triple it, it will be triple. See, this is a graph. Delta V versus I. Potential difference versus current for this conductor. This graph is a straight line. It is obvious because they are directly proportional. If the current is I, potential difference is 10 volt. If the current is 2I, potential difference is 20 volt. If the current is 8I, potential difference will be 80 volt. More is the current, more is the potential difference, or vice versa, and directly proportional. If potential difference increases 2 times, current also increases 2 times. So graph is a straight line. Okay. So delta V is directly proportional to I is Ohm's law, provided temperature remains same throughout the experiment. Now I remove this proportionality sign and I will get a constant. When you remove proportionality and give a sign of equality, you get a constant. And this constant R is called resistance. This is constant. It won't change for the given conductor. Until you change this wire, until you throw this wire and bring some another wire, R will not change in the experiment. So R is a constant for a given conductor. If you increase potential difference, current will increase, but R will remain constant. R depends on conductor. Until you change this conductor, R will not change. R depends upon conductor. But if you see this formula, R is equals to delta V upon I. Delta V upon I. This formula gives a misconception that resistance is directly proportional to potential difference. It seems like this. If I ask you, does resistance depends upon potential difference? If looking at the formula, you will say yes, but it does not. Resistance depends on conductor. How is that true? Why not? The formula for density, mass upon volume. But density does not depend upon mass or volume. It is constant for a given material. The formula for refractive index, speed of light in that medium upon speed of light in air. Refractive index is constant for a given medium. So these are constant. R is a constant in this equation. R does not depend upon potential difference or current. R depends only on conductor. R is a constant. Okay. So this much is Ohm's law. Delta V is directly proportional to I, or delta V is equals to IR. R is a constant for a given wire. Delta V increases, I increases. Temperature should remain constant. One more very important discussion over here is regarding the slope of delta V versus I. Slope of delta V versus I. This is a graph of delta V versus I, and it is a straight line on increasing current, potential increases, or vice versa. What is the slope of a graph? What is the formula for slope? If you know it, good. If you know it, it is equals to tan of theta, where theta is this angle. Tan of theta, or it is equals to y2 minus y1 upon x2 minus x1. Both ways it is correct. y2 minus y1 upon x2 minus x1. So if I apply this formula, what is on the y-axis? It is potential difference. So it will be v2 minus v1, and over here will be I2 minus I1. On the x-axis is current, on the y-axis is potential. If this is slope, and slope is the angle. If you understand slope, slope is just angle. The angle it makes, it calls slope. The angle it makes with the x-axis, with the positive x-axis, with the positive x-axis. If the graph makes is like this, the angle is 0. Angle increases. So the angle a graph makes with the positive x-axis is the slope. And slope is y2 minus y1 upon x2 minus x1. v2 minus v1 upon I2 minus I1. That is delta V upon I. Change in potential upon change in current. And this is exactly resistance. So the slope of delta V versus I graph is R. Change in potential upon change in current. Delta V upon I, it is resistance. The slope of this graph gives us resistance. Gives us resistance. See, over here the angle is theta. Over here the angle is theta. Current is changing, V is changing, but theta is not changing. Theta means what? Slope is not changing. Slope means what? Resistance is not changing. Resistance does not depend upon delta V to I for ohmic conductors. Ohm's law is valid only for ohmic conductor. Very important. Ohm's law is not always valid. This delta V is directly proportional to I is valid for ohmic conductor. What is an ohmic conductor? Copper is nearly an ohmic conductor, which follows Ohm's law, which obeys Ohm's law are ohmic conductor, like copper, like silver, like metals, most of the metal wires. But silicon is a non-ohmic conductor. Its delta V versus I graph is not a straight line. The slope of the line does not remain same. Water is not an ohmic conductor. So every conductor is not ohmic. Ohm's law is valid only on ohmic conductor. So this graph is true for ohmic conductor. Resistance is constant for ohmic conductor. So this was about Ohm's law and resistance. But coming back to the point, resistance does not depend on delta V or I. Resistance does not depend upon delta V or I. So resistance depends only on the conductor. What is resistance? Constant for a conductor. And this is how resistance depends. If this is a conductor and current is flowing like this, current is going like this. This is the cross section which current is crossing through, and this is the length the current is covering. So resistance is equals to rho. This is known as rho. Rho L by A. Rho L by A. Rho L by A. L length, A area. This L is length, A is area. This rho is resistivity. Resistance depends upon conductor, and every conductor has different resistivity. Every conductor has different resistivity. It is property of the material, property of the conductor. Like density is a property of a material. It does not depend upon anything else. It only depends upon material and sometimes temperature. Yes. So resistivity is a constant which is a property of material. Like I take two examples, then only it will be clear. Here is a thin copper wire and here is a thick copper wire. A thin and a thick copper wire. What is the relation between their resistance? Which will have higher resistance? Resistance inversely proportional to area. Thicker is the wire, more is the space for current to flow, and less is the resistance. Thicker wire, area is more, resistance is less. Thicker is the wire, current can go more easily, and hence resistance is less. Resistance is what? Obstruction to the current. So, a thicker wire has lesser resistance and a thin wire has more resistance. This thin wire has more resistance and this thicker wire has less resistance. Resistance is an obstruction to the flow of current. Resistance stops current from flowing. This was a definition of resistance. Now I have taken a short wire and a long wire. Which will have more resistance? Resistance directly proportional to length. A longer wire will have more resistance. If these two are made of silver and again silver. For these two, resistance is less for thicker wire. Thicker wire has low resistance. But what about resistivity? Resistivity will be same for both wire because it depends on material and the material is copper. So resistivity does not depend upon area. What about these two? Both are made of silver, material is same, resistivity will be same for both material. That is okay for both the wire because the material is same. Resistivity depends only on the material from which it is made. If I made a cup of copper, if I made a tank of copper, if I made a wire of copper, all will have different resistance because resistance depends upon length and area, but all will have same resistivity. So resistivity is independent of length or area, but resistance depends upon length and area. Okay. So for both these wire, resistivity will be same, and for both these wire, resistivity will be same. We'll do numericals and get to the core of the topic, that how to solve R, rho, L, A. What are these equations? Okay. Here I have a wire made up of, say, copper, of resistivity rho and having area A and length L. Here I have another wire having length L but area 2A, and this wire is also made up of the copper. So resistivity will be same for both. If the resistance of this wire is given as 4 ohm, find the resistance of this wire. How to solve such question? For both of these, L and A are different, so resistance will be different. But since copper, the material is same, the resistivity will be same. So I write R is equals to rho L by A. What is R? 4. 4 is equals to rho L by A. Over here, I write R dash is equals to rho L by, the area is 2A. Rho L by 2A. So rho L by A multiplied by 1 by 2. What is rho L by A? It is 4. So 4 by 2, it is 2. The resistance of this wire is 2 ohm if the resistance of this wire was 4 ohm. So this is the method to solve these questions in which the material remains same, resistivity will remain same in your syllabus. Okay. So resistivity won't change and will remain same. So you find resistance of another wire. Resistance depends upon length and area, resistivity does not. Very, very interesting question. A wire, very interesting, of length 10 centimeter has resistance 2 ohm if the wire is stretched to double its length, find new resistance. So I have a wire whose length is 10 centimeters, so I supposedly say it L, 10 centimeter. Now I stretch this wire and double its length. If I stretch this wire and double its length, it will get thinner because the volume will be same, so it will get thinner. So I have increased the length to 2L, the cross section area will change, and that's how resistance will change. The resistance of this wire is given to us. A wire of length 10 centimeter has resistance 2 ohm. On stretching the length, area decreases and resistance will become R dash. Suppose this area is A and this area is unknown, I call it A dash. That is A, this is A dash. Now the formula for resistance will be rho L by A, and rho L by A is equals to 2 rho L by A. Since both are same material, on stretching the material does not change, resistivity will be same in both cases because both are same material, property of material. So resistivity is same in both cases. On stretching, resistivity does not change. On compressing, resistivity will not change. Okay. Now this side I write the formula R dash is equals to rho 2L by A. So it will become A dash. Area has also changed. So rho. Now how to do this? For this we have to apply volume conservation. Volume of both wire is same. Okay. Yes or no? The volume for both the wire is same. So we apply volume conservation, and volume of first wire is equals to volume of second wire. The formula for volume is length into breadth into height. Length into breadth into height. Length into breadth is area. So area into height. Height is length. And this side area A dash into length. Volume is area into length. Area into height. L cancels. A dash is equals to A by 2. So this is A by 2. Now rho 2L A by 2. 2 will go upside. Rho L by A multiplied by 4. Value of rho L by A is 2. 2 4s are 8 ohm. Resistance of new wire will be 8 ohm. So on doubling length, area becomes half. If you double the length, area becomes half A by 2. If you triple the length, area becomes 1 by 3. If you make length 4 times, area becomes 1 by 4. Since volume has to remain same, A into L is equals to A dash into 2L. LL cancels. So this is the way to solve these questions of stretching. Resistivity will remain same. Length, if it's stretched, area will also change. Rho 2L by A by 2. 2 goes upside. Rho L by A 2. Okay. A similar question, a very similar question. A wire of resistance 9 ohm is doubled on itself. Find new resistance. So here is a wire whose length is not given. I take it as L, whose resistance is 9 ohm. The length is not given, okay? So I took the length as L. Area is not given. I take the area as A. And resistance is 9 ohm. Now this wire is doubled on itself. It is doubled on itself. It is folded on itself like this. It is folded on itself. This much wire has been taken from this side and folded like this. Now the length will remain same, but area is A and A. So area becomes 2 2a, and length will be what? L by 2, because it is double. This is L, so this will be L by 2. So length becomes half, area doubles. That's also volume conservation. Length becomes half, area becomes 2 times, or you see AA. Now the resistance of this wire is R dash. What will be same for both? Resistivity. So we write R is equals to rho L by A. In place of R, I write 9. Rho L by A is equals to 9. From this side we will write R dash is equals to rho L by 2 upon 2A. Rho L by 2 upon 2A. Fine. It will be rho L by 4A, or rho L by A multiplied by 1 by 4, and rho L by A is 9. 9 by 4. So the answer will be 9 by 4 ohm. This is the method to solve the stretching or the doubling type of question. Okay. If I triple it on its length, not double. If I triple it, length will become L by 3. Triple it, and area will become 3A. Then you can solve R dash is equals to rho L by 3, 3A. So this is the method to solve these questions. If length is doubled, area will become half. If length is halved, area will become double. And rho will remain same in both the cases. Now there is a question. 2 wires having same length but radius R1 and R2, find the ratio of their resistance and resistivity if they are made of same material. So we have 2 wires whose length are same. There are 2 wires whose length are same. This is also L, this is also L. 2 different wires having same length. But radius R1 and R2. This has radius R1, this has radius R2. You understand what is radius? Radius is this thing now, R. That's circular cross section area. This is R. So we have to compare, we have to find the ratio of their resistance and resistivity. Since both are made of same material, resistivity will be same. So resistivity will be same. So resistivity of first upon resistivity of second will be rho by rho, that is 1 by 1, 1 is to 1. So resistivity will be same for both. But we have to compare resistance also. This is R1, this is R2. Resistance of first wire, resistance of second wire. So R1 will be equal to rho into length upon A1, and R2 will be equal to rho L upon A2. Now I divide R1 upon R2. What will happen? Rho L will cancel. This is inversely proportional. This is inversely proportional. So it will come like A2 upon A1. Now what is the area of this wire? This is now A2. This is A2. What is the area of circle? Area of circle is pi r square. Area of circular cross section is pi r square. So A2 will be pi R2 square. A1 will be pi R1 square. Pi cancel. R2 upon R1 square. So the ratio of the resistance R1 is to R2 is R2 square is to R1 square. Okay. So this is the method to solve such kind of questions. So this was resistance. The formula is rho L by A. Resistance depends upon length and area. Resistivity depends upon material. The unit for resistance is ohm. The unit for resistance is ohm. The unit for resistance is ohm. Okay. Delta V upon I. The unit is ohms. Okay. Okay. Resistance delta V upon I. Unit of this is volt. Unit of I is ampere, and this volt upon ampere is called ohm. Also written as like this, ohm. Delta V upon I is called ohm. Okay. And the unit of resistivity, R is equals to rho L by A. So rho is equals to R A by L. R A by L. R is ohm, A is meter square, length is meter, so the unit is ohm meter. Unit of resistance ohm, unit of resistivity ohm meter. This is ohm and this is ohm meter. Clear? Clear? Okay. Now the next big thing is that on what factor resistivity depends. You said it is same for a given material, but it depends upon temperature. Resistivity depends on temperature. The property of material depends upon temperature. How? For conductor like copper, as you increase the temperature, resistivity increases. On increasing temperature, this constant resistivity increases. What is resistance? What is resistivity? It is the obstruction to the current. Obstruction to the current is stopping current from flowing is resistance. Resistance stops the current. So resistivity is also the property of stopping current. So more is the temperature, kinetic energy of each molecule inside the conductor will increase. Electron will suffer collision with them and current will decrease. More is the temperature, the random motion of molecules inside the conductor, the atoms, the ions will increase. Electron will collide more, and since electron will collide more, resistivity will increase. More resistance, more resistivity. For semiconductor, on increasing temperature, resistivity decreases. For conductor, more is the temperature, more is the resistivity. Formula for resistance, rho L by A. So if resistivity increases, resistance should also increase. If resistivity increases, resistance should also increase. So for conductor, on increasing temperature, resistance, that is the obstruction to the current, is stopping the current, this property increases. The property is resistivity and resistance. Okay. But for semiconductor, on increasing temperature, resistivity decreases. So resistance also decreases. Why? There is a question why. For them, the number of ions increases. As you increase the temperature, number of electrons, number of ions, more ions are now into the conduction. So there is more number of ions. So the flow is easier and resistance is less. And this is the phenomenon of semiconductor, which is much way beyond your syllabus. It is not like electron phenomena. This is a different thing. Okay. But anyhow, on increasing temperature, resistivity decreases and resistance decreases for semiconductor. And there are then some alloys like manganese. For manganese, if you increase temperature, resistivity remains constant. So for some alloys, the resistivity or resistance remains constant, nearly constant. It changes, but changes a very small amount on increasing temperature. If I draw a graph over here of resistivity versus temperature, then this will be like this. On increasing temperature, resistivity increases. Over here, the graph of resistivity versus temperature will be like this. On increasing temperature, resistivity is decreasing, becoming less. And if I draw the graph of resistivity versus temperature for alloys, then it would be somewhat like this. It is not exactly a straight line. It is somewhat constant. Type of constant. Resistivity remains nearly what? Same. Not increases in much amount. Just the same over this distance. So these are the graph of resistivity, as well as if asked for resistance. As resistance depends upon resistivity, this could also be the graph of resistance versus temperature. Okay. So resistivity now depends upon two factors. One factor being the material and the other factor being temperature. And by now, resistance has been depending on four factors. See, resistivity now depends upon material and temperature. And resistance has a formula rho L by A. So it depends upon length, area, material, as well as temperature. So these are the factors on which resistance and resistivity depends upon. Resistivity does not depend upon length or area. It is constant for a given material. What is resistivity? Let me give you the feel of resistivity. What exactly is resistivity? I took this wire and I asked you, what is the resistivity of this wire? If someone asks you what is resistivity, you cut a small wire from this, whose length is equals to 1 meter and whose area is equals to 1 meter square. The length of this wire is 1 meter and area is 1 meter square. You cut a wire from this. You have been asked the resistivity of this whole wire. Resistivity depends upon material, does not depend upon length or area. So you cut a small wire from this. The resistivity of this much wire will be the resistivity of that much wire because it does not depend upon length and area. So you cut this wire of length 1 meter and area 1 meter square. And you find the resistivity of this. How? How will you find it? You connect it to a potential difference of 1 volt. Connect it to the potential difference of 1 volt. Okay. And find the current flowing in it. Whatever the current is in this. By this equation, you can calculate the resistance of this wire. Because resistance is equals to delta V upon I. You can get the resistance delta V upon I. You have calculated the current and voltage. You have applied it and seen it. R is equals to rho L by A. Now here length is 1 meter, area is 1 meter square. So this is it. Length is 1, area is 1 meter square. Resistivity is equals to the resistance. Now you have been given this much sample, find the resistivity. You cut a small part of length 1 meter, area 1 meter square, put it in a potential difference of 1 volt, measure the current. Measure the current. Now find the resistance, delta V upon I. Now you know the resistance because you have measured the current, applied the potential difference. Now you have the resistance, R is equals to rho L by A. L is already 1 meter, area is 1 meter square. R is equals to rho. So the resistance of this wire that you have calculated should be equal to the resistivity of the material. You are given a big copper tank. Find the resistivity of copper tank. You are sure resistivity depends upon material. You cut a very small wire of length 1 meter, area 1 meter square. You find the resistance of that wire. R is equals to rho L by A. You know how to calculate resistance. You calculated resistance and set it is equal to resistivity. So resistivity of a material is the resistance. Resistivity of a material is the resistance of a wire of length 1 meter and area of cross section 1 meter square. Clear? Resistivity of a wire is the resistance of that wire of length 1 meter and area 1 meter square. Okay, so if I ask you what is the resistivity of water, what will you do? You will take water and construct a wire of water of length 1 meter and area 1 meter square. And you will find the resistance of that much water, and that will be called the resistivity. Resistivity of a material is the resistance of the wire of that material of length 1 meter and area 1 meter square.